Hello guys, this is Dr. Possibility from Excel Academy. Kindly make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. In this tutorial, I'm just going to do my part 2 of tutorial sheets, and this tutorial sheet is just tutorial sheet 1 of Math 1100. So please make sure that you check out my part 1. So I'll look at question 4, question 5, and question 6, and I'll make sure that I simplify everything in a simple way. So let's quickly get started and look at question 4. So question 4 is saying, show each of the following interval on the number line. So I'll quickly show these intervals on a number line. So I'll write my solutions like that. So when you talk about the number line and the number line and the interval, one thing that you need to understand is the representation and the meaning of these brackets. So the first type of bracket is this one or that one. So these brackets, they normally mean part of the set. They normally mean part of the set. So these ones, they normally mean part of the set. And when representing this type of brackets, you normally use the shaded circle. So this is how you show these guys. And then the other type of brackets which you need to know, it is this one or that one. So this type of brackets, they simply mean not part of the set. So this one is not part of the set, okay, not part of the set. So these are the other type of brackets that you have to make sure that you take note of. And this type of brackets, they are represented on a number line using the unshaded circle. So with this just little knowledge which I've shared here, you are able to change these intervals which you have been given into the number line. So let's quickly get started and look at these questions and solve them in an easy way. Please, if you have any questions, make sure that you register with Excel Academy, or you can ask in the comment section and me and my team will surely respond to you. So let's quickly look at these questions since we have given the approach you're supposed to use. So I'll start with the first one. So let's assume that the universal set is a set of real numbers. So we are starting from the negative infinity to positive infinity, negative infinity to positive infinity. So once we do that, we can represent this given set on a number line such that we can simply put a 0 as a demarcation of negatives and positives. And then you look at this bracket. So if you look at this bracket, it is a block bracket. And this type of bracket is simply mean that this -1 is part of the answer. So I'm going to put -1 there, and then I draw a line up. And since it's part of the answer, I'm going to use the shaded circle. Then from that, I'll go and look at 1. So you have a 1 there, and the 1, it is also part of the answer. So I'll put a 1 there, then draw a line on top and shade it like that. So after doing this, what I'll do is I'll just connect these sets. So this simply means that -1 and 1 are part of the answer, and all the numbers in between them, they are also part of the answer. So the numbers in between -1 and 1, these include the rational numbers, irrational numbers, the integers, and many other type of numbers you can talk about. So from here, we can simply move on and look at this other part, which is our 2. So if you look at our 2, it is also a simple question which you can easily do. So I'll easily sketch my my number line, and in this case this will be negative infinity, and this is positive infinity. So make sure that you take note of the universal set which you have been given. In case this is not the universal set, then automatically you won't put real numbers as your universal set. I think one of my videos has such a questions, and in case you have any queries of such, you can easily register with us. So this will have a 0 there as a demarcation, and then I'll quickly look at what I've been given. So I've been given negative 4 open. So in such a case, I'll go and press where negative 4 is. So I can put negative 4 anywhere and then draw a line on top. So if you look at negative 4, it's not part of the set. So I'm going to use the unshaded circle. And then I'll quickly put a comma and put a 1, and then 1 is having that block bracket. So in such a case, I'll put a 1, draw a line on top. Since 1 is part of the answer, I'll simply use the shaded circle. After that, I'll just easily connect these two sets. Then let's quickly look at question 3. So I'll look at question 3. So question 3 is something which is negative 4, 1, and of which both of them are not part of the set. So I think since I've already given an highlight on what you're supposed to understand about the bracket, I think now this question is just a walkover for you guys. So from here, what we can simply do, we are just going to simply look at this bracket here. So this bracket here, it is just it's just saying that negative 4 is not part of the set. So we are going to draw a line on top. We put negative 4, and since it's not part of the set, you are going to put unshaded circle. Then you have a 1 there, you put a 1 there, and then since 1 is not part of the set, you are also going to put the unshaded circle. And after that, you can just easily connect these two. So once you write this, then you have just represented open negative 4, 1, and then open. Very easy and straightforward. Let's quickly move on and look at question 4. Part 4, you have been given negative 1, infinity. This is a very nice and interesting question, such that this time around we are involving the infinity. So for you to represent this set, you just simply sketch like that, and then this side you put negative infinity, that side you put positive infinity, and then in between you put a 0 to put the demarcation between negatives and positives. Once you are done with that, you can represent this work on a number line in such a way that you're going to put a negative 1 there. You draw a line up, you analyze, is negative 1 part of the answer? The answer is no. So you're going to put like that. Then this negative 1 has been paired with positive infinity. So you can't put a line on top and put that. No. What you're just going to do is you're going to draw an arrow pointing towards positive infinity. And this is how you can represent such a set on a number line. So let's quickly look at number 5, which is my last guy. So the last guy is more like the opposite of the other one, just that this time we have negative infinity and also 0. So you put negative infinity, then you put positive infinity this side. Then you put a demarcation, which is a 0. But this time around, this question is a little bit different, such that this time around we are starting on 0. So we are starting on 0. Then you're going to check, is 0 part of the answer? The question is yes. So you are going to shade like that. And in which direction are you going to go? You're going to go in the direction of negative infinity. So you just draw a line going this side. That's how easily you can solve these questions. But remember that these questions, they are just forming the basics of what we are going to talk about on question 6. So make sure that you understand this, and then as we do question 6, you'll be able to understand and do everything clearly. Let's quickly look at question 5. So question 5 also, you're going to relate it. So for this one, things you need to know, since we are talking about set builder notation. So one thing you need to understand is that when you talk about this bracket or that bracket, it simply means not part of the set. I've already explained that. So these brackets, they normally go with that or that. So these are the two brackets which are used when you're talking about not part of the set. Then the other brackets are the block bracket or close bracket. Take note that these brackets are known as open brackets, and then these ones are closed brackets. So these brackets, they normally go with less than or equal to or greater than or equal to. So these are the brackets that you normally use when you are relating set builder notation to interval notation. So one thing you need to understand is that the number line, set builder notation, and interval notation, they are related. Okay, they are related. So with this being said, we can easily do number 5. We can easily do number 5 in an easy and simple way without having any difficulties. So let's start with the first one. So the first one, what I'll say set A is simply equal to, you say open brackets such that x is a member of real numbers. Okay, then you say such that you're going to put -10 there. Okay, and then since this bracket is not part of the answer, so you're going to put a less than without an equal to, then you put an x, and then since 10 is part of the answer, you're going to put less than or equal to 10, and then that will be your answer for this question. With that in mind, we can do question 2. So for this one, you simply once again say b is equal to, you're going to say brackets, and then you say x is a member of real numbers. Since x is a member of real numbers, such that you're going to write that 4. So you're going to say 4, and then once you write 4, you put less than or equal to. Since 4 is part of the answer, so you put less than or equal to. Then you are going to say x, and then 9 is part of the answer, you say less than or equal to 9, and then you put the bracket. Please guys, if you have any questions, feel free to comment in the comment section, and also make sure that you register with Excel Academy. Our classes are both physical and online, and the good part of joining Excel Academy is that we are going to give you as many quizzes as possible, as many tests as possible. We are also going to give you handouts, assignment, and many things that will help you to excel at the university. So make sure that you register with us, and make sure that you subscribe to our YouTube channel. Number 3 is saying you have C, so you say C, and then you say x is a member of real numbers. Then you say such that you're going to easily get that -1, you put it there. Then since this is the bracket, which is an open, you're just going to put a less than, then you put an x, and you write that 5 there. You write it like that. So you just don't have to write it like that. So what you have to do is you analyze the bracket which is on 5, so it is the block bracket, so you're going to put less than or equal to 5 like that, then you put the bracket. The last one, it's a little bit unique and a little bit different from the guys, but it's a very easy one to do. So you're going to say D is equal to, you're going to say X is a member of real numbers. X is a member of real numbers, such that you are simply going to write the X there, and then you, since 0 is part of the answer, you're going to say greater than or equal to 0. Then that's the final answer. So these are the ways you can change the interval notation to set builder notation. And you can also change this same set builder notation to interval notation, and later on you can change them to the number line. So let's quickly look at the last question in this tutorial class. And my last question is this guy here, which is question 6. So I'll write my solution. So for this solution, what I'll do is I'll read out the question. So let R be the universal set. So I'll write my data there. I'll say data. So I've been given that the universal set U is R, which is real numbers. So this R stands for real numbers. So that simply means that we are moving from negative infinity to positive infinity, like that. Then we have been given set A, which is simply this one, and set B, which is simply that one, and then set C, it is that guy there. So I'll write set A to be equal to open 1, -1, comma 6, and then block bracket, which is closed. Then B, we have been given B, which is simply open 0, comma 4, like that, which is very easy. This question is very easy. So the deal is on C. So C is something that has been written as open bracket X, such that X is greater than or equal to 4. So this is also another representation of the sets in set builder notation. I think for those who have registered with Excel Academy, I've also taught them this way of representing. So X is a member of real numbers, like that. So what you are going to do is you're going to change this guy into the interval notation. So when you change this guy into the interval notation, what we are just simply doing, we are doing the opposite of D, where we are solving this guy. So we are just taking this to that. Okay, so what we are going to do in this case, we are going to say since 4 is part of the answer, since there is an equal to there, since there is an equal to, then 4 is part of the answer. So what I'll do is I'll put a block bracket, and the direction where it's pointing toward the positive infinity. So I'll put block bracket, I say 4, comma positive infinity, and then open, like that. So once I change C into interval notation, then I am able to do everything that I've been asked in this particular question, which is very easy and straightforward. So from here, what I'll simply do is this. I'll go to question 1, which is have been told to find A minus C. So what I'll do is I'll draw a number line. I'll sketch a number line like that. And on this number line, I'll indicate the universal set. Never forget to put the universal set. And then you make sure that you put the demarcation, which is a 0 there. So when you do that, what you are going to do now is to present these sets on a number line. So since we are looking for A minus C, so I'll put A on the number line. So what I'll do is I'll put -1 there, and then I'll also put 6 there. So if you look at what we have, it is open -1. That simply means that we are putting the unshaded circle on top of -1. Then 6, it is with the block bracket. So we are going to put the shaded circle on top of 6. And then we connect these two sets like that. So this is set 1. This is set A. Then I'll get set I'll get set C. I'll represent it on the same number line. So set C is 4 to infinity. So set C is starting from 4 here to what? To infinity. Is 4 part of the answer? Yes, it is. So I'll shade 4 into this guy, and then I'll go to positive infinity like that. Once I'm done with that, I'll go back to the question and analyze and ask myself, which region are they simply asking me to consider? So since we are saying A minus C, so A minus C, from A you remove C. So from red, remove green. So if you remove green from red, this is the part which is remaining. So this is simply the part which is remaining. So this is our answer, like that. Okay. Now, from this answer, you need to analyze what are you really supposed to consider, because it's not everything that you are considering there. So from this answer, I'll come up with a way. So if you look at if you look at C, when removing C from A, you are going with 4 because 4 is part of C. So that simply means that when you are removing C from A is not remaining with the 4. So that means that in our answer, 4 is not part of the set. But if you go this side, you try to put -1. -1 is not affected. So you are going to put the same bracket and connect them. So this simply means that our solution is as follows. So our solution is as follows, such that you have A minus C, which is simply equal to this -1 will be open, so it will be -1 open, comma, and then what you are going to do is you are simply going to say 4, which is there, so you put a 4 there, and then 4 is open also, so this will be like that. So this is how the answer was. So if you want to represent this guy on a number line, you can just easily do that. You say negative infinity and then positive infinity. And then from there, you put your demarcation as a 0, and then you write this set on a number line. So this will be -1, and then that one will be 4. Of which both are what? Both are open. So both are open like that. And then you just connect them like this. So this is the A minus C. Then you are done. After you're done with that, we can go to 2. We can do 2. So for 2 is also very easy. So what you're going to do for 2, this is how you're going to approach it. Remember that, say you have been given B complement intersection C, and then you have a complement. Personally, I don't really love dealing with complements. So what I can say is this is the same as C intersection B complement. This is according to the commutative law, and then this can also be written as C minus C B, and then complement up like that. So the law I've applied to change C intersection B complement is the difference law, and then the first law I utilized to exchange those guys, it is the commutative law. Check out our video on the algebraic laws of sets. I think I've explained all that. So from that, we can now easily start with open bracket C minus B, close bracket, complement. So we'll specifically start with C minus B. So you sketch your diagram like that, and then this is negative infinity, and this is simply positive infinity. Then 0 as your demarcation. So when you put that, you're going to put C and B on the same number line. So I'll start with C. So C I'll start with B. I'll start with B. So B is 0 to what? 0 to 4. 0 to 4. So since B is 0 to 4, I'll start where 0 is. So I'll put on top 0 like that. Is 0 part of the answer? No. So it will be unshaded like that. Up to what? Up to 4. So where is 4? So if you look at 4, 4 is this side, and then I'll put my 4 there. And then I'll analyze, is 4 part of the answer? No. So this guy will be also unshaded, and then I connect them like that. So this is set what? This is set B. Then I'll write set C on the same number line. So set C is starting from 4, but this set C, 4 is part of the answer. So I'll write the same 4, I'll put it on top. Okay, I'll put a set on top of set 4, set B. So there, and then it will be shaded, and then it will go this side. So this is set C, and the red guy is simply set what? Set B. So from what we have found, we are saying from C remove set B. So from C remove set B. So if you look at this set, when you are removing set B from set C, you are not going to remove anything, due to the fact that 4 is not in B, but it is in C. So this 4, when you are going with 4, when you are removing B, as you go out with B, the members of B, you are not going with 4. So C has not been tempered. So C minus B is the same as C. C minus B is the same as C. So C minus B is just the same as what? The same as C, which is the same as what? Which is the same as 4, positive infinity, the one which we simply found. So once you find this, just for those who are maybe behind, I'm going to indicate the region which we are considering as the answer. So this is our region according to the answer. So this is the region we are talking about, the one I've highlighted. So with that thing, so what I'll do is I'll now solve for C in minus B complement. C minus B complement. So that will be my next target. So in that case, what I'll do is I'll put my number line like that. I'll put my number line like that. Then there I'll put like that. And then I make sure that I put a 0, and then this side there is negative infinity, and the other side there is positive infinity. So if you look at this number line, remember there is positive infinity here, and there is negative infinity this side. So what I'll do, I'll draw this line on the number line. So I'll put a 4 like that, and remember that 4 is part of the set like that, and then this set is going this way. So to find C minus B complement, since we have found that C minus B is the same as C, now we need to look for C complement or C minus B complement, which is this question. So what I'll do is, on top of this guy, I'll put another arrow like that. Then when we are removing C minus B from the universal set, since it's complement, so we are comparing it with the universal set. So this guy will be open on top, and then it won't go this direction, it will go in the opposite direction. And this is our answer. This part is our answer. So if I was to represent this work on a number line, I can say C minus B open bracket complement. It is a set whereby I have the universal set going this side and that side, negative infinity, positive infinity, and then I have a 0 as my demarcation there. And then what I've observed is that I'm going to have a 4 which is going to be here, and then this 4 is not part of the set, like that, and then it will surely just go this side. So if I was to represent this in set builder notation, this guy is the same as open negative infinity comma 4 open, like that. So this was the final answer. So if you check my solution is in such a way that it is short as compared to someone who might want to say B complement intersection C, and then they multiply that complement throughout to have B union C complement. Such people, they'll end up having what? Having some long method. They might get the correct answer, but their method is very long. Yeah, their method is very long. And in math, you need to look at the time. Let's go to C. Let's look at the third part. So I'll write solution like always. Then this one is saying C minus A open brackets intersection B. So what I'll do here, I'll simply indicate a number line. So I'll have my number line like that. So this side I have negative infinity, the other side I have positive infinity, and then in between there is a 0. So in such a case, what I'll simply do is that I'll first start with C minus B. I'll first start with C minus A, I'll first start with C minus A. So I'll show set A and set C on the same number line. So set A is having a -1, and -1 is not part of the answer, up to 6, and this 6 is part of the answer, which is shaded. So this is set A, like that. And then set C, what I'll do, I'll also represent it on the same number line. So set C is starting from 4. I think I've explained much about these sets on representing them on a number line. And then this guy is what? Is shaded, and it's going this side. So the question is, from C remove A. From C remove A. So when we remove A from set C, which part are we remaining with? Which part are we remaining with? So from here, what you can observe is that when you remove set A from C, remember black is C and green is A. So what you are remaining with is this particular part. Okay, so this is the part which you are remaining with. Now, on this same part which you are remaining with, one other aspect which has to come in is for you to analyze the interval where this set is ending. So if you look at A, this is A and this is C. A is in green and C is in black. So if you look at A is ending on 6. So as you remove A, you are going with 6 because this 6 is part of A. So in short, for your answer, it will go up, and then C is not part of the answer, open, and then you are going this side. So what you have now, C minus A, which is this one, C minus A. It is a set which is having 6 comma positive what? Infinity, because 6 is not part of that answer. So this is C minus what? C minus A, like that. Then from that, what you can easily do now is to find C minus A intersection B. So you are going to represent C minus A on a number line with B. So let's quickly do that and look at how the final answer will look like. So you have that, you also have that. So this is negative infinity and that is positive infinity. Then 0 as your demarcation. So you're going to draw C minus A on this number line. You're going to draw C minus A. So C minus A is starting from what? It's starting from 6. C minus A is starting from 6. So you put 6, of which 6 is not part of the answer, isn't it? Yeah. And then this is going in this direction. Then you are going to draw B on this same number line. So let's quickly draw B. So what is B? B is 0 to 4, right? B is 0 to 4. So you put your 0 there, and 0 is not part of the answer, up to 4 there, which is also not part of the answer, like that. So you connect them. So this is your B, this is your C. Then the question is, find C minus A intersection B. Is there a part where these guys are meeting? The answer is no. There is no other part. So therefore, you have to say C minus A open bracket. Okay, C minus A open bracket. You are now going to say intersection B is simply equal to an empty set. So the answer here is an empty set. Have we been asked to illustrate this on a number line? Yes, we have been told. So a number line of an empty set, it's something that just goes this side and it also goes that side without anything on it. It's just an empty number line. Nothing is on an empty set. So this is how you easily illustrate an empty set, and that was it, the final answer. Okay, let's quickly go on 4. Let's quickly go on 4 and look at how 4 is. So I'll say solution, and then for 4, what I'll do is I'll draw a number line once again. So this is positive infinity, this is negative infinity. So I'll write negative infinity, positive infinity, and then 0 as the demarcation. So after I do that, what I'll simply do, I'll put set A on a number line. So I have to illustrate set A, which is the negative infinity up to what? 6. So I'll go up negative infinity, then up 6, which is the shaded like that. Then I'll make these guys to meet like that. So this is set A. Now what we are looking for is the set A complement. Okay, what we are looking for is set A complement. So the region which we are simply looking for, it is this region. This is the region we are focusing on, the region which there is no set A. So this is the region we are looking for, and this is also another region we are looking for. So as we look for this region, the only thing that is needed is for us to just analyze this region. It's just for us to analyze this particular region. So if you look at -1 is not part of set A, so that means that it is part of A complement. It is part of A complement. So you go like that. Then if you look at 6 is part of A, so it's not part of A complement. So it will go like that. So this side, it is A complement. This side is also A complement. So what we are having, A complement is simply equal to, you're going to say open negative infinity, comma, -1 is part of the answer. So you say block like that. Then you say union, because there is also other this part. So you're going to say open, since 6 is not part of the answer, then 6, comma, positive infinity, and then you say open. To represent this on a number line, this is how you're going to illustrate it. So you're going to have that. Here you have negative infinity. This side you have positive infinity. And then you have 0 as your demarcation. After you do that, it's just a walkover thing. Just represent that set on a separate number line. So there you're going to have -1, of which is part of the answer. And then you go on the left, and then you get 6, which is not part of the answer. Open, and then you go on the what? On the right. So guys, this was the final answer for this particular question. So I'll give you the assignments, and for this assignment you should make sure that you send it in my inbox. So for this one, you should find from the same set, you should find A intersection B complement, and then you can also find a set which is B minus A and then open bracket union C. So these are the two questions I'll give you from this question, which you should make sure that you submit and make sure that you contact us. So ladies and gentlemen, in case you want to get in touch with me, in case you have any question, in case you have any clarification, please make sure that you WhatsApp us on the lines which are showing on your screen. Thank you very much guys for joining me. This was Dr. Possibility from Excel Academy.